Okay, so we were looking at how to compensate your linear regulator or LDO. So, what we needed, first thing we needed to break the loop, because we are looking at open loop gain, and then you need to find the poles and or zeros if there are, which means, so in order to find the poles, what we need to look at. So, we know the pole is one over RC, which means we need to find nodes with high R and C. Okay. So, this was our diff pair. And what I have at the output of this, a P transistor, which was your pass transistor or the output power FET, which is driving your R load. Okay. So, now we have a capacitor here. If I call it CO1, sorry, CO2. Let me CO1, change the color for this also, CO2, and then I have another cap which is your C out. So, what we are looking at, 3 potential nodes which may have poles which fall into within your UGB. Okay. So, if I call it omega P1 pole, this is giving me omega P2 and this is giving me omega P3. Correct. So, how do we find that omega P1? What is omega P1? So, 1 over. So, what is the capacitor at this node? How many cap we have here? So, if this is M1, M2, M3. So, remember this, you have a gate to bulk, gate to drain, gate to source. So, each transistor is having 3 different caps. Okay. So, the M1 device, since gate and drain are shorted, so there is no CGD, but you have a gate to source and gate to bulk. So, I will just add up them together because they will be added up ultimately, because they are coming into parallel, because your bulk and source both are tied to VDD common point. So, let us say I call it CO1 into RO1, which is the R out looking at that node. So, what is the RO1, R out at that? So, if you consider that transistors are in saturation, then RDS is pretty high. Okay. So, it will be defined by CO1 into 1 over GM1, correct, which means 1 over CO1. This is with the assumption that GM1 is or I would say RDS is much larger than 1 over GM1, correct. So, they are in parallel. So, your effective resistance will be determined by which were the lower term, and since 1 over GM1 is lower. So, in saturation drain current ID is given by 1 by 2 mu Cox, or I will call it mu P because we are if you are looking at PMOS, mu P Cox, what else, W by L VGS minus VTH. I am putting in mod because we are interested only in the positive value. Okay. So, this is your equation, and GM is nothing but over delta VGS. If you differentiate it, what you get? You get mu Cox W by L VGS minus VTH. Okay. So, VTH is approximately 500 millivolt for 180 nanometer CMOS. And VGS minus VTH we usually use approximately 100 millivolt, that is our drive voltage we target. So, in order to achieve 100 millivolt, whatever the bias current you have here, and for a particular GM you can always find the size, transistor size. Okay. So, let us assume your ID is 10 microamp and W by L is what else, let us say 10 over or not this 10 over 1 micron. So, 10 micron width, and so can you find the GM? Mu Cox is, mu P Cox is, you can assume roughly 50 micro amp per volt square. So, your GM is 50 micro multiplied by 10 multiplied by 100 millivolt, which comes about how much? 100? 100 millis? How come 100 milli? So, this is 50 micro, this is 10 and this is 100 milli, which is 0.1. 50, huh? 50 micro Siemens or ampere per volt, correct. 100 milli is your VGS minus VTH. So, this is 0.1 into 10 is 1. So, which means 1 over GM is what? 20K, correct, and your capacitor, so C gate or C gate to bulk is roughly 5 femto per mm per micrometer square. That's it's not a very accurate number, but when you start your simulation you can find it. I think it's 6.5 or so, but I am just putting rounded off number 5 femto. So, now you know the area which is your, I am ignoring the overlap cap because I am considering that that is going to be smaller, roughly like less than 1 femtofarad. So, 10 multiplied by this. So, your area is 10, 10 is the width and 1 is the length. So, your total cap will be this is C gate to bulk. If you simulate, it will show you as a CGG, which will show you in fact overall cap. So, this is per micron square. So, CO1 I would say. CO1 is 10 times into 5, which is roughly 50 femtofarad. Okay. So, 20K and 50 femtofarad, that will give you the pole. So, where is the pole? Omega P1 is approximately at 1 over 20K multiplied by 50 femtofarad. 1 giga 1 giga radian per second, okay, which is very high. Your UGB is not going to be 1 giga for sure, it will be order of tens, maximum tens of megahertz, not more than that. So, we can ignore omega P1. Now, let us look at the second pole, omega P2. So, there is no GM term here, only R out. So, we have to consider, we cannot ignore now R out here. So, 2 R out in parallel. So, if I call it Mn1, Mn2. So, 1 over RO1 of, sorry, not RO1, RO2, yeah, RO2 in parallel with not RO1, RO2N, okay, P and N, then CO2. So, what is CO2? So, how will you calculate RO1 and RO2? The currents are same. So, what is R out? Formula for R out or RDS I would rather say. RDS is 1 over lambda ID. What is lambda? Channel length modulation, okay. So, and lambda is approximately I think 0.5 to 1 per volt for L equal to 180 nanometer, and lambda is inversely proportional to L. If you make a larger L, it will reduce. So, make it 10 times, then lambda will go maybe 1/10 of what you considering. L equal to 1 micron. because we already saw W by L, that is what we consider. Na? So, for 1 micron what will be that? So, 1 by 0.18 roughly 5 times. So, okay, so your lambda will be approximately 1 by 5, 0.2. If you consider 0.5 then 0.1, if you consider 1 then, so which means 0.1 to 0.2 per volt. Okay. So, let us assume lambda equal to 0.1 in this case, and ID equal to 10 micro amp. So, what is R01? By the way, this lambda might be different for PMOS and NMOS, but for simplicity let us assume same for a calculation, but when you start your simulating you may get a different number, but that is fine. I mean, you will just want to give you idea how you find the R out actually. So, R0, it is R02. So, or let us calculate, let me see what we define it. R02 equal to 1 over 0.1 into 10 micron, which is 1 mega, and R02N also 1 mega ohm, correct. So, and they will be in parallel. So, your R02 will be 500 kilo ohm.